Hey everyone, it's Kelly, and we are going to do a little cell notation work today. So here is the following example. Let's get straight to it. If I give you, let's use maroon because that's fun. If I give you a sample equation, so we have chromium plus some copper, yeah, the 2 plus goes to the 3 plus version. And then we've created copper solid. There's just a simple generic oxidation reduction reaction. I want you to be able to figure out its cell notation and then build its half reactions from this information. So if we pick out another fun color, let's actually just figure out the half reactions first, because then that will help us do the cell notation. And because we need to figure out what's oxidized and which one's reduced. If you can't see it quickly, that's totally fine. The way you want to do these types of problems is pick out, similar species. So you have a solid chromium going into its ionic form. So that those are clearly related somehow, right? So I'm just going to write them out. Chromium solid is somehow going to the ion. Okay? Oh, there's an A in there. Good. And then on the flip side of it, you have your copper ion going to a copper solid. So copper ion. Wow, I can't do A's and Q's today. That's okay. A and then copper solid. So at that point, you can figure out, which one's being oxidized and reduced just by looking at the charge kind of difference at that point. So you'll notice on this left-hand side, this chromium has an oxidation state kind of 0, right? And it's changing to +3. So something's happened electronically, right? So at that point, you're going to want to balance the charge. So if you have a +3 on the right-hand side, and to make that equal to 0, so it's currently +3, currently this is 0. The only way you can do that is by adding electrons to the right-hand side, and we're going to add 3 to balance that out. So you'll notice that a -3 and a +3 is a 0, okay? Because you're always adding negatives. That's the only way you can kind of balance these things. You're adding a negative, so you're going to try to get as close to the higher positive number, or maybe they're both negative. Excuse me. So that, we're essentially adding 3 negatives to the right-hand side for that equation, and for the copper side, it has to be the other way around. It has to be adding to the left-hand side if this is a correct example, okay? And you'll notice that this is 0, and this left-hand side is +2. So we're going to be adding 2 electrons to the left-hand side. So if this is a true oxidation-reduction reaction, one side has to be a reduction and one has to be oxidized. So I'm noticing that this left-hand side equation is gaining electrons. We're gaining electrons because it's on the left-hand side. This copper 2 plus is adding 2 electrons to its system to become a solid. Now, what is gaining electrons? Is that an oxidation or is that a reduction? Give you a moment. And it is a reduction reaction. Okay. Now, if we go to the left-hand side, if we're correct with the reduction side, we better know that this is oxidation. But just to confirm it, it is losing electrons because of this guy right there. It's kind of like these 3 electrons are being lost off of this chromium solid. So we're losing electrons. So this is your oxidation. Okay. So so this is really useful, just kind of being able to look at an equation, an overall equation, and parse it out, okay? If we wanted to actually balance the charges at this point, you could start adding coefficients to the front of this reaction, because technically it is not balanced in that regard, right? But that will be for a different type of video, because I just want to cut to the chase and get the actual cell notation indicated at the bottom here. So cell notation is kind of just a new way of looking at an oxidation reaction, and in your cell diagrams, you're going to see anode and cathode indicated, And essentially, the form is the oxidation side is on the left, or the anode. And then on the right-hand side will be the reduction side, or the cathode. And what you have in between, so you're going to have two lines here, which form the salt bridge. And then you have single lines indicating phase change. Phase change. So now we can just fill it in. So let's do, oh gosh, I'm frozen by indecision on colors. Let's do dark blue. Okay, so we know that the oxidation side is this chromium side, okay? And the way we read it from left to right is the chromium solid has a phase change into the chromium 3+. It's aqueous. And then on the right-hand side, we know that it's reduced. The copper is a reduced side. So we have the copper has a phase change into its solid form. Okay. This right here is your cell notation at the bottom. And you can start drawing a big diagram with two beakers and electrodes and a salt bridge and whatnot. And that could be also, questions you would get. But this is just the straight up simple notation where the left-hand side of the salt bridge is the oxidation side. The right-hand side is the reduction side. And then you start parsing out your different phases based on your ions or solids or whatnot. So hopefully this clears up a little bit of how to take an overall, like just a generic overall reaction and put it into cell notation form. So practice these because they are never going to go away in electrochemistry.